Welcome to ECE 376 Embedded Systems for Fall 2022. I'm Jake Lauer, your instructor, and this is kind of an overview of the course. Now, in my opinion, this is kind of one of the more fun courses in the electrical and computer engineering program. Embedded systems is basically hardware that's controlled by software. So this is basically the lab for all the courses in ECE. I've got the hardware interfacing, so that's all the circuits, electronics, talking to microprocessor, programming, get the microprocessor to do something, and coordinate it, control the outputs based upon the inputs. So that's the fun thing. That's typically the reason people go into engineering. You want to build stuff. And it really helps if you have a microprocessor. Well, that's this course. So I'll kind of walk through what this course is all about. This is the homepage for embedded systems. If you go to Bison Academy, that's bisonacademy.com, that's the semi-official homepage for the electrical and computer engineering department. Click on 376. That'll take you to this course. And on here, I've got the course laid out on a daily basis. These are the topics that we'll be covering. The lecture in both a portrait and landscape format. Portrait is nice for printing out. Landscape is nice for presentations. Under videos, all the lectures have been recorded and posted over here. In case you miss a lecture or you love it, want to relive it one more time. There's a YouTube playlist in case you want to invite your friends and neighbors over and binge watch it. Sample code, stuff that we go over in class, so you don't have to type it in by hand. Just click on it and there's your code. Along with homework sets and solutions. Now, currently the homework's not posted, but they will be shortly. Also, there's a couple other links. Old homework sets and solutions. These are from previous semesters. Best of 376. With your permission, if you made a video showing off your homework solutions and you allow me to share them, I'll share them right here, so you can see what other students have did in previous semesters. Information on the lab kits. We'll talk about that shortly. Programming is a whole lot more fun if you have something to program, so you'll be building one of these boards at the start of the semester. So that's what it should look like when you're done. If I can figure out how to get out of here. And various resources. Like the PIC data sheets, that's actually the real lecture notes for this course. That's about 500 pages of data sheets for microchip. If there's a discrepancy between the lecture notes and the data sheets, the data sheets are probably right. Microchip actually has really good data sheets. They're accurate, which isn't always the case, and fairly easy to read. Various C compilers. To program your board, you need MPLAB 8.92. That's what I recommend. Download that first, then download the C compiler and run it, and you'll have the C compiler when we get to C, otherwise assembly. To download your code, you'll need HyperTerminal or the PIC Flash tool. PIC Flash tool is kind of nice. But anyway, we'll talk about that in just a sec. So going on to the syllabus. So, information for this course. Again, I'm Jake Lauer. Class meets Monday, Wednesday, Friday, 1 p.m. in Ag Hill 326. The lab times, this is an open lab. You can use ECE, I think 311 or 327. I think those are right. Pretty much anytime, 24/7. The boards are set up if you have your own computer or your own laptop. You don't really have to come into lab. You can program at home. My office hours are Monday through Friday, 8 to 10 a.m. Typically on Zoom. I'll have Zoom up and running if you want to hop on Zoom. Otherwise, I'm in ECE 201. There is no textbook for this course. All lecture notes, information like that is on Bison Academy. The bulletin description is the use of microcontrollers for data acquisition and device control. Includes assembly, high-level programming, serial and parallel I/O, timers, interface design. The prereq is the ECE 173, C programming. If you forget your C programming, don't worry about it. The main thing we need in this course is what is a subroutine, for loop, do loops, if statements. That's about it. 275 is required. That kind of gives the idea of things being set, cleared, ring counters. We'll be doing most of that in software rather than hardware though. And circuits 1. To interface the PIC to various devices, you'll need some information from circuits 1, like op amps, voltage division. Again, if you're kind of rusty on that, we'll cover that in class. The objective of this course is by the end of the semester, you should be able to solder your own circuit board. Again, you'll be soldering because we used to have graduates who never soldered their entire life, and that just doesn't seem right. You should solder at least once before you graduate. This is a class where you get to do that. You should be able to interface a microcontroller to binary inputs and outputs, be able to interface a microcontroller to analog inputs and outputs, and be able to control the outputs based upon the inputs using programs written in assembly in C, and be able to use a thing called interrupts to control the precise timing of a microcontroller. Again, everything is on Bison Academy, the semi-official website for the ECE department. If you click under ECE 376, you get this page, the syllabus. On the syllabus, I've got the content on a day-by-day basis, videos for the recorded lectures, a YouTube playlist in case you want to invite your friends and neighbors over and binge watch all the videos, sample code, and homeworks. Homework is due the following week, and what typically the homework's due on Monday, then we'll go over it on Wednesday. So Wednesday, the homework solutions will be posted. As long as you get the homework in before the solutions are posted, I'm okay with that. Kind of takes the fun out of doing the homework if you've seen the solution. If you get stuck on the homework, the second tab over is Homework Sets and Solutions. This course has been running for quite a while, so I've taken the old homework sets, I make new ones every semester, taken the old homework sets and posted them under Homework Sets and Solutions along with a solution from that semester. Now, occasionally I'll also have YouTube videos explaining how you do the homework. That's for the last couple semesters where we went online. For the people that take the class online, this is kind of a solution describing how you do it in case you missed class. These are also useful for later semesters if you want to get an idea of how to do this type of problem. So the homeworks and solutions are a pretty good resource if you get stuck and you need some help. Next tab over is Best of 376. That's kind of a fun site that shows off stuff that students have done previous semesters. Oftentimes people make videos to validate their homework, and then with your permission, I will then post the videos. So like here's a car parking sensor using interrupts to measure time to 100 nanoseconds and a range sensor, determine how far your car is from the back wall, and light up a bar chart based upon distance, change color when you should stop. Refrigerator data logger, how many times does the refrigerator door get opened over the night, and so on. One thing I do recommend is do make videos. One feedback we've gotten from industry is that everybody's resume looks the same on paper. I used to work for Fisher Controls, and when you interview people, it gets really mind-numbing seeing the same resume day after day after day. If somebody has a video showing what they've actually done, it makes the interviewing a whole lot more interesting, and you tend to remember the person. Plus, you get to direct the conversation during the interview. You're going to talk about something that you're very familiar with. It's your homework assignment. Videos are nice because videos that worked last year work this year, versus hardware that worked last year may or may not work. Stuff gets cannibalized, falls apart, breaks. So do make videos of your projects. It's also a nice way to validate that you actually did the work. I've noticed a couple semesters under validation, you need to collect data to prove your device meets the requirements. And oftentimes that's kind of lacking in the written portion, but shows up on the video. So as long as you collect some data, validate it either in writing or in the video, you'll get credit. Videos are kind of a good backup in case you forgot to collect some data. The lab kits. Now, programming is a whole lot more fun if you have something to program so you can test your code. The whole point behind this class is take some inputs, feed that to microprocessor, implement some algorithms, then drive the outputs, so you can actually see your device working. The lab kit is a board you're going to build during the first 2 or 3 weeks that you'll be using throughout the semester. It's also really useful in senior design. If you need a microprocessor in senior design, this is a pretty good processor. The lab kits are available for $65 from SWE, cash or check. You can pick up in my office, ECE 201, and it allows you to test your code. For the lab kits, the $65, it's actually about $100 in parts, but SWE buys the parts in bulk over the summer to help save you money. If you, for some reason, don't want to buy them from SWE, the parts list is available so you can pick up your own parts if you want. If you find a board from a previous semester, that doesn't count. Part of the goal of this course is to give you experience soldering, and finding somebody else's board that already works doesn't really do that. So soldering isn't that hard once you do it, but you need to do it a couple times to get used to it. Again, you learn by doing. On your circuit board, I've got about a dozen spare boards. If your board quits working, don't panic. Just stop by my office. I can usually debug it. I can also swap out your board with a board that works. You need a working board. The course is a whole lot more fun if you have a working board to program. If your board doesn't work, come see me. I can swap it out. I'll get you a working board. Again, I've got like a dozen that I build over the summer. Typically, the reason the board quits working is you have a bad solder joint, meaning it's just a mechanical connection. The solder isn't actually melted to connect it. What happens is that over time, the solder oxidizes, opens up the connection. If you take your board and twist it, and it works, doesn't work, works, doesn't work, that's a sign of a bad solder connection. I can usually fix that just by flipping the board over, put the soldering iron on each pin for about 3 seconds, remelt it. That usually clears the problem. If not, it might take a little bit longer. But again, I can usually fix it. I've done this for quite a while. Or I can swap out a board with you. In terms of how you take the course this spring, actually, this is for fall 2022. Sorry about that. Draw. Fall. You can take the course any way you like. The course is offered in person, live streamed, and online. In person, masks may or may not be required. I don't really know. Depends upon what NDSU's requirement is at the time. Live streaming, you can wear a mask if you live stream it just to feel like you're part of the class, or you don't have to. Or online. All the videos, all the lectures are recorded and posted on YouTube. Everybody's welcome to use the online resources. You can also change how you take the course on a daily basis. If you want to show up in person on Monday, live stream on Wednesday, watch the video on Friday, I don't really care. What I tried to do in setting up the course, I try to make it so that the online is just as good as in person. It's not, but I'm doing my best. I've got 30 years experience teaching in person, 3 years experience online, so not surprisingly, in person is better than online. But again, however you want to take it is fine. In terms of in-person versus online, I have collected data. The course evaluations are about a letter grade higher for the in-person people. They enjoy the course more. The grades in the class are about half a letter grade higher for in-person versus online. So in-person is better than online. Be that, make sure you understand that. But again, how you take the course is up to you. Again, I'm trying to make online just as good as in person, but I'm trying. It's not, but I'm doing my best. In terms of evaluation, this course is going to have 3 midterms, homework sets due once a week, a term project at the end. The term project is combined 2 or 3 homework sets together in one big design, more elaborate homework set, or an experiment, such as are NDSU mugs better than UND mugs, that sort of thing. Something that uses a PIC processor and knowledge from a couple different lectures. That's the term project due at the end of the semester, and the final exam also at the end of the semester. The average of these 6 is your overall grade. And grounds are rounded to the nearest 1%. And I'll round down, but not round up. So if everybody gets an A, or everybody gets 90%, I'm happy to give out all A's. I'll have to explain that to my chairman, why that happened. But if you can demonstrate knowledge of binary inputs and outputs, analog inputs and outputs, assembly programming, C programming, and interrupts, you got an A. That's really the objective of the class. I also do that because if you work together, Winston kind of commented to me that they worked in a group before, helped the other 3 people, so on a curve they hurt themselves. I don't want to discourage you from helping each other. So if you help everyone else, you're not hurting yourself. If you want to get an A or B in the class, I highly recommend doing the homework. This programming is like weightlifting. Watching somebody else lift weights really doesn't do much for you. You got to do it yourself. Same thing with programming. If you watch the videos and say, yeah, I get it. Watch me go through the solutions and say, yeah, I get it. Then you get to the midterm and fail horribly. That's actually pretty common. You got to write the programs yourself. You got to figure it out yourself. The best way to learn how to program is to do it. So if you do the homework, you should do fairly well on the tests. And typically grading in this class is bimodal. I've got one group of students getting an A and a B, another group of students struggling to get a D. I think what's happening is you've got the students that did the homework, understand the material, the students that are watching the videos and not actually doing the work, and the second group. Again, like weightlifting, if you watch somebody else do the programming or write the program, it doesn't really help. You got to do it yourself. In terms of the homework and the lab projects, you can work in groups of 1 or 2. Part of the reason is once you get 3 people in your group, typically one person gives moral support. Boeing actually did a study. When it comes to programming, 2 they found is optimal. Once you get 2 people in the group, if you get stuck, hopefully the other person can help you get through it. Versus 1, if you get stuck, you're kind of stuck. Once you get to 3, again, one person gives moral support. So ideally work in groups of 2. Groups of 1 are also fine. The exams, however, are working alone, individuals. The exams serve as a check that you're doing the homework. If you do the homework, the exam should be pretty straightforward. If you're giving moral support or copying your code that you found online, you're probably going to struggle during the tests. So again, do the homework yourself. If you work in groups, make sure you understand what's going on. And the homework tends to be open-ended. We'll cover something like how to measure time, 200 nanoseconds in class. Then the homework is measure something. Your reflex time, how high you can jump, the frequency of a square wave, your pick. So they're open-ended assignments, and you're free to specify what you're going to build and program, subject to including things that we're covering that week in class, like stepper motors, measuring time. Each homework set has 4 sections. And again, this is feedback we've gotten from industry. The typical analysis that you do on homework is just a very small part of the engineering design. The whole design process is requirements capture. What are the inputs? What are the outputs? What's to do? Requirements are all important. They drive the design. The second part is hardware and software, the analysis that you're kind of used to. Testing and validation. Test to see, does your hardware work? Test to see, does your software work? Then validating, do you meet the overall requirements? And demonstration. Demonstrate that your program works either in person or in a YouTube video. That allows you to tailor the homework to your own interests. Also makes my job easier since they don't have to come up with new homework sets every semester. In terms of legal stuff, attendance is mandatory, but it's your choice, in person, online, live stream, however you want to attend. If you have any special needs, let me know and we'll figure out how to accommodate you. In terms of academic honesty, kind of the point behind that is the stuff you learn in this class you're going to need when you get to industry. Our graduates build defibrillators, pacemakers, flight controllers, stuff like that. You need this information when you get to your job. If you figure out a way to get through this class, get an A and not learn anything, then you're really hosed when you get to senior design or get to industry. You'll have a hard time getting through the job interview when they start asking you questions. Typically, they'll grill you during job interviews to find out, do you actually remember what you supposedly learned at NDSU? If you get through the job interview, then you are going to be asked to apply what you've learned. It's a whole lot easier if you learn the stuff in college before your job depends upon it than having to learn it once you get on the job. So, again, this isn't just make work. This is actually stuff you're going to use. And really, this is the whole reason you go into engineering. You want to build stuff. This is the class where you get to build things. I can build, theremins, a little device where the frequency varies with your hand distance. I can build reflex timers. I can build clock, things that will pick a lock, fun stuff like that. And I guess other legal stuff. So again, this is a fun course. I really enjoy it. Hope you're going to enjoy it as well. That's kind of the course overview in terms of the topics that we'll be covering. Let's go through that. We'll start out the class covering assembler. Assembler is machine code, really hard to use, really cryptic, but really fast. Part of the reason we do that is that everybody should suffer through assembler at least once. So we'll do that for 4 weeks. We'll also look at how to program your microprocessor, get binary inputs to it, binary outputs, drive LEDs, then drive NeoPixels, then the first test. We'll then switch over to C programming. C is nice because it has things like addition, subtraction, multiplication, arrays, for loops, do loops. C code is way easier than assembly. We'll look at how to do things like drive your LCD display, read a keypad, read analog inputs, collect data from sensors. Once I have the data, how do you analyze the data? A little bit on statistics. We'll then look at a thing called interrupts. Interrupts are really confusing. Interrupts are subroutines called by hardware. So in your code, you're going to have subroutines being called by someone other than you. It's really powerful if you can figure it out, but they're kind of confusing. Timer interrupt says, say every 10 milliseconds, I trigger the interrupt. If I count interrupts, I know time. An INT interrupt is when I hit a button, I call a subroutine. So these are different ways of calling subroutines based upon hardware events rather than software events. We'll spend quite a bit of time on interrupts. That's a really important feature of this course. A little bit of filter design. Anything I can design in hardware, I can do in software. In hardware, I'll build a filter using capacitors and inductors, stuff you cover in 321 analog electronics and 311 circuits 2. Here we'll be doing it in software. And then we run out of time. So again, that's the class. Hope you enjoy it. It's a fun class. It's basically the lab that goes with the entire ECE program. And with that, we'll let you go, and we'll pick up on Friday with computer architecture and Boolean math.